Welcome back, Achievers. In this video, we're going to learn a new technique for solving quadratic equations called the quadratic formula. Before we get into that, let's do a little bit of a review of what we've already learned. So far, we've learned two techniques for solving quadratic equations. We learned how to solve by factoring as a product of two binomials, and we also learned a technique called completing the square. When we're solving by factoring, we're trying to rewrite this quadratic as a product of two binomials. We were looking for two numbers that multiply to this third term here and add up to this middle term here. So the numbers that multiply to 20 and add up to negative 12, you could figure that out by dividing 20 by the first natural number, 1, all the way up to the square root of 20, which is 4 point something, and you don't have to check past that. So I'm building all my factor pairs of 20 right now. 4 is the next number that goes into it. 3 doesn't go into it evenly. And I wrote out all these factor pairs right here. You can see that the pair of numbers that multiplies to positive 20 and adds up to negative 12 is negative 2 and negative 10. So we're going to rewrite this quadratic x squared minus 12x plus 20 as the quantity x minus 2 multiplied by the quantity x minus 10. So we just factored this, and now since this times this equals 0, we can say that one or perhaps both of them equal 0. That's called the zero product property. We're going to equate each one of these binomials to 0 and then solve from there. Adding 2 gives us x equals 2. Adding 10 gives us x equals 10. So our quadratic equation has two answers. X is equal to positive 2 and x is equal to positive 10. All right, let's do another example. This one has a decimal, and we're not going to be able to factor that like we just did the first problem, but we can use what's called completing the square. X squared plus 3x minus 15.8125. In order to complete the square, we always start the same way. We take half of the x coefficient, we square that, and we add it on both sides of the equal sign. So half of 3 is 1.5. and 1.5 squared is 2.25. So all I did was I took half of 3 and then I squared it. That's 2.25. I have to add that on both sides of the equal sign. Otherwise, I'm changing the problem. As long as I add it on both sides, I'm not changing the problem. All right, now what we've created is what's called a perfect square trinomial here. X squared plus 3x plus 2.25 is a perfect square trinomial, and that can easily be factored as the square root of x squared, which is x, the square root of 2.25, which is 1.5, and then we use the sign of the x coefficient, which is a positive sign. So we have x plus 1.5 squared. And now we're going to get rid of that 15.8125. The negative 15.8125 by adding it on both sides of the equal sign. And that is going to give us 18.0625. Alrighty, and we have x plus 1.5 squared is equal to 18.0625. And now to get rid of that squared, we're going to take the square root of each side. When we take the square root, we have to remember that there's always a positive principal square root and a negative square root. Taking the square root of this 18.0625. All right, that worked out relatively nicely. That's 4.25. So we have x plus 1.5 is equal to 4.25. And of course, the negative answer to that square root, x plus 1.5 is equal to negative 4.25. Now we have to solve each one of these independently by subtracting 1.5. So our one answer is 2.75, and our other answer, negative 4.25 minus 1.5, is equal to negative 5.75. So we have two answers. X is equal to negative 5.75 and x is equal to positive 2.75. In our last video, I talked a little bit about the fundamental theorem of algebra, which says that the degree of a polynomial equation tells you how many real roots that equation can have up to. So when we solve quadratics, they can have up to as many as 2 real answers. All right, let's do another question down here, number 3. Gotta scroll down a little. 2x squared plus 6x minus 20 is equal to 0. This is another situation where we're going to use the completing the square method. So we're going to take half of that x coefficient. Actually, we haven't done any like this in a while. This one leads with a 2 in front of the x squared. So I'm actually going to make that one look like question number 2, where the leading coefficient is 1. To do that, I'm going to divide the whole equation by 2 before I do anything. I'm going to divide everything by 2 on both sides of the equation. All right, my resulting equation is x squared plus 3x minus 10 is equal to 0. Now I'm going to use completing the square. I'm going to take half of the x coefficient, square it, and add it on both sides of the equal sign. Half of 3 is equal to 1.5, and 1.5 squared is 2.25. That's what I have to add, 2.25. All right, so what I've created here is called a perfect square trinomial, and that can be factored as a binomial squared. I'm doing that right now. And I had minus 10 there. All right, to get rid of that minus 10, move it to the other side. I'm going to add it on each side. 2.25 plus 10 is 12.25. So my new equation is the quantity x plus 1.5 squared is equal to 12.25. The quantity x plus 1.5 squared is equal to 12.25. And we're going to get rid of that squared by taking the square root of both sides. And I have to remember to consider both the positive principal square root and the negative square root. And the square root of anything being squared is itself. That's why I did that, to get rid of that squaring. So I just am left with x plus 1.5. And the square root of 12.25 is, let's find out, 3.5. So that's the positive principal square root. The calculator will give us that answer. And the one we have to also consider is negative 3.5. That's the other number that when squared is equal to positive 12.25. All right, so we have to solve this by getting rid of that 1.5 that's being added to x by subtracting it. X is equal to positive 2. And x is also equal to negative 5. 2 answers, 2 and negative 5. All right, let's get into this new thing. We are going to come back to question number 3 and do it again in a moment. We're using the new technique that I'm about to teach you. But all of these problems always look the same, right? They're quadratics. So they have some general form, and it's some number times x squared plus some number times x plus some other number, and that is equal to 0. This is the standard form for a quadratic equation. These coefficients in front of x squared, we usually call that a. In front of x, we usually call that b. And the constant at the end, we usually call that c. Any quadratic can be written in this form, this standard form. Now, if we wanted to use the technique we just did, completing the square, we could do that to this one. The first step I did in question number 3 was I got rid of that 2 in front by dividing by it. So I could divide everything by a. I'm going to begin by doing that. So what I'm trying to do right now is solve for x, and then we'll have a general recipe that would give us the answer in terms of coefficients a, b, and c. All right, so my new equation becomes x squared plus b over a times x plus c over a. This is a little bit advanced because I'm deriving the quadratic formula for you, but I think it's worthwhile so you can see where it actually comes from. All I'm going to do is the same technique I just used in question number 3, completing the square. I'm going to take half of the x coefficient and square it, and I'm going to add it to both sides. So half of b over a is actually b over 2a. All I did was I took half by putting that 2 down in the denominator. And I also have to square that. So I'm taking half of the x coefficient, which is b over 2a, and then I'm going to square that and add it to both sides. B over 2a squared. Now what I've created is what's called a perfect square trinomial. X squared plus b over a times x plus the quantity b over 2a squared is a perfect square trinomial, and that actually can be factored as the square root of x squared goes in the front, and the square root of b over 2a squared goes here, which is just b over 2a. So I factored that perfect square trinomial as a binomial squared, and now I'm going to clean this up a little bit. I'm actually going to square out that b over 2a squared. Squaring numerator, b squared is b squared. And squaring the denominator, 2a times 2a, is actually 4a squared. Now I'm going to move this c over a to the other side by subtracting it from both sides. And I'll write the answer up here. I ran out of room. X plus b over 2a, that quantity squared, is equal to b squared over 4a squared minus c over a. Now, when you subtract fractions, it's important that they have the same denominator. So I can actually make equivalent denominators by multiplying by 4a, multiplying the top and the bottom of c over a by 4a. And that way it will have the same denominator as this other fraction. So this is now x plus b over 2a squared is equal to b squared minus 4ac all divided by 4a squared. I just combined those fractions. All right, I'm almost there. I want to clean this up a little bit more. I'm solving for x. X is being added by b over 2a, then it's being squared. It's time to get rid of that squared by taking the square root. Still using the completing the square technique that I used in question number 3. All right, so this is plus or minus the square root of b squared minus 4ac. Now, I can take the square root of the denominator, 4a squared. The square root of 4a squared is just 2a. So there's a rule in algebra that the square root of a quotient is equal to the quotient of the square roots, and I was able to take the square root of the denominator, so I did. All right, there's only one more step. I have to get rid of that b over 2a that's adding my x. So to get rid of that, I'm going to subtract it from both sides, subtracting b over 2a. And what do we have here? We have x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, since they have the same denominator, I can combine that fraction bar, and let me do that here. The final way that I'm going to write this is how it's usually written in textbooks. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's actually what's known as the quadratic formula. And it seems complicated, and I did just go through the steps of deriving for you. You never have to do that. I just wanted to show you where it comes from. This is a really famous formula. It gives you the answer to any quadratic equation. And all I did to derive it was I just started with a very general quadratic ax squared plus bx plus c is equal to 0, and then I solved for x in terms of a, b, and c, where a, b, and c are the coefficients of some general quadratic. You could go ahead and do a Google search, quadratic formula. The things that's going to come up is that formula that I highlighted at the bottom there. And let's see how it works. Let's use it in action here. So the quadratic formula is a special formula for solving quadratics when they're written in standard form. You can find it on the internet all over the place. I was forced to memorize it when I was in ninth grade, and I don't think it's too hard to memorize, and it's something that if you do enough problems with it, you'll realize that this is probably the easiest technique for solving quadratic equations. So let's revisit question number 3 and actually use this quadratic formula this time. So this is the same problem we did in question number 3 on the do now. So we are going to get that same answer that we got before, which was, let's see, it was 2 and -5. Let's make sure we still get 2 and -5. So always begin by writing out the quadratic formula, identifying your coefficients A, B, and C, and then just plugging them in to the formula. So our coefficients A, B, and C are 2, 6, and -20, and they're going to get plugged into that formula. I color-coded it for you. So I like to just rewrite out my formula, but I leave a blank spot and an open parentheses wherever the A, B, and C are. And now I'm just going to write them in there. So the first thing we write is negative whatever B is. B is 6 in this case. I'm going to put a 6 there. Plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. All right, this is when I go into my calculator. Get my fraction bar, -6 in parentheses, plus or minus. There is no plus or minus button on this calculator, so you actually have to do it in 2 steps to get both of your answers to the quadratic equation. So I'm just typing this in exactly how it appears. Parentheses and everything. Now, if you use the stacked fraction as I'm using in this calculator, you don't need an extra set of parentheses around the denominator, but if you're using a more basic calculator, you're definitely going to want to put an extra set of parentheses down that denominator to make sure you're dividing by 2 times 2 and not dividing by 2 and then multiplying that answer by 2. I see a lot of students having that issue when they use some more basic calculators. So I have a more advanced calculator that has a stacked fraction, and that fraction bar is interpreted as a grouping symbol, so it will divide by the product of 2 and 2. All right, so I'm going to hit enter, get my answer. 2 is my one answer, so x is equal to 2. And now I'm just going to go up to that previous entry and change that plus sign to a minus sign. It was plus or minus the square root, so now we're going to do minus the square root. So all I did was change that to a minus sign and get my other answer, -5. And that should be no surprise because we already saw that the 2 answers to this question were 2 and -5. All right, let's do another quadratic formula problem. Solve this quadratic. All right, normally this would be a pain to factor or use completing the square, but now we have the quadratic formula, and we can just begin by writing it out. -b plus or minus the square root of b squared minus 4ac, all divided by 2a. It just kind of rolls off your tongue. Here it is. So we're going to just write in our coefficients a, b, and c. Sometimes you can write them out off to the side. Maybe that'll be helpful. A is 5, b is -25, c is -70. It's important you get those signs correct. They're very important. All right, I'm going to put in my a, b, and c. So it's -b plus or minus the square root of b squared minus 4ac, so a times c, all divided by 2a. So I had to just replace a, b, and c wherever they were in that formula. Now, you could just use your calculator to do this. It's probably easier. -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 multiplied by a. And my answer is 7. X is equal to 7. And my other answer, x is equal to, let's find out. All I have to do is consider the other square root. I did plus the square root. Now I have to do minus the square root of this. -2. So the two answers to this quadratic equation are 7 and -2. Another one. Probably a good idea to begin by writing out the quadratic formula. -b plus or minus the square root of b squared minus 4ac all divided by 2a. All right, and now I'm going to identify my a, b, and c coefficients. The coefficient of x squared is 3, the coefficient of x is -12, and the constant at the end is +12. Negative b means negative of a -12 plus or minus b squared, -12 squared, minus 4 times a is 3, times c is 12, and then in the denominator 2 times a, so it's 2 times 3. So just going to go ahead and type this into my calculator. Negative b plus the square root of b squared. These parentheses are very, very important. Minus 4 times a times c, all divided by 2 multiplied by a. The answer is 2. X is equal to 2. And our other answer, x is equal to, let's find out. We did plus the square root, now we have to do minus the square root. That was also equal to 2. That's weird. So this happens once in a while when the radicand is equal to 0. Plus or minus the square root of 0 is going to give you the same answer because the square root of 0 is 0, and that's the one number that doesn't change when you add it or subtract it. And yeah, so one way that you could check your work is to graph them, and where they hit the x-axis is what the answers are. And you could see in this problem why there's only one answer and it's 2. It's because it only hits the x-axis at one spot. So I'm going to graph this just to show you what that looks like. The answer is 2, so it should only hit the x-axis at +2. Let's see. Yep, it only touches the x-axis right there at +2. So quadratics can have up to 2 real answers, but that doesn't mean they have to have 2 real answers. They might only have one answer. So this one actually only has one answer, and it's just 2. So once in a while, you can have ones that don't even hit the x-axis, and they have complex answers or imaginary answers. All right, another example. 2x squared plus 2x minus 12. Well, to get that, we're going to begin by writing out that quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And then we identify a, b, and c and just plug them into the formula. Coefficient of x squared is 2, coefficient of x is 2, constant at the end, -12. Negative b, so -2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 2, times c, which is -12, all divided by 2 times a, which is 2 times 2. So we got to type it in our calculator. Or if you want, you could do them by hand. I'll show you one where we do it by hand. X minus -2 plus or minus the square root of 2 squared, which is 4, minus 4 times 2 times -12. 4 times 2 is 8. 8 times 12 is 96. So we have 8 times -12 is -96. This will be 4 plus 96. All I did was -4 times 2 times -12, and that's why I changed it to a plus, because it's a negative times a positive times a negative, which is a positive. All right, and then the denominator, we had 2 times 2, which is 4. So we have x is equal to -2 plus or minus the square root of 4 plus 96, which is 100, all divided by 4. So this is x is equal to -2 plus the square root of 100, which is 10, divided by 4. And x is equal to -2 minus the square root of 100, which is 10, divided by 4. So x is equal to -2 plus 10, which is 8, divided by 4, which is equal to 2. And the other answer is negative 2 minus 10, which is negative 12, divided by 4, which is negative 3. So our two answers to this problem, x is equal to negative 3 and positive 2. And that's typically how people write their answers. They just separate them by a comma. X is equal to negative 3, comma, positive 2. And another fail-safe you could do to check your work, you could graph it. This one should hit the x-axis at negative 3 and positive 2. 2x squared plus 2x minus 12. When I hit graph, it should hit at negative 3 and positive 2. Let's see. Definitely hits at negative 3 and positive 2. This is correct. All right, one final example. 2x squared minus 3x minus 5 is equal to 0. We're going to begin by writing out that quadratic formula, and then we're going to plug in a, b, and c. It's important that you plug A, B, and C in the correct spot. I've had a lot of students accidentally put in A here, B here, and then C here just from, I guess, getting so used to putting things in alphabetical order. You have to put B in where you're supposed to, which is here and here. All right, so we have negative of a negative 3, which is a positive 3, plus or minus the square root of negative 3 squared, which is 9, minus 4 times 2 times negative 5. Now, negative 4 times 2 is negative 8, times negative 5 is actually negative 40, or positive 40. Negative 4 times 2 is negative 8, times negative 5 is positive 40. So that ends up being 9 plus 40, or 9 minus negative 40, same thing. And in the denominator, you have 2 times 2, which is 4. So this is x is equal to 3 plus or minus the square root of 49 divided by 4. So x is equal to 3 plus the square root of 49, which is 7, divided by 4. And x is equal to 3 minus the square root of 49, which is 7, over 4. So 3 plus 7 is 10. 10 divided by 4 is 2.5. And 3 minus 7 is negative 4. Divided by 4 is negative 1. So our two answers to this question are 2.5 and negative 1. All right. Now, if you really want to be going the extra mile, I've had some students in the past write a program on their calculator that will actually program in the quadratic formula for you. I can upload that in my next video and show you what that looks like. That will only work if you have one of these TI-84s, but it's a nice little exercise to practice programming. Thank you for watching the video, and please try some of these quadratic formula problems that I uploaded for you on Google Classroom. I look forward to meeting with you in our next video meeting on June 1st, and thanks again for watching.